Let's derive an identity for sine of 3x using only signs. Sine of 3x, first of all, can be written as sine of 2x plus x. So break apart the argument in here like that. So apply the next rule that says it's going to be sine of 2x cosine of x and then plus cosine of 2x times sine of x. That's a rule that you can use. Now for sine of 2x, you can write 2 sine of x cosine of x. So I'm rewriting, this is the red part here, okay? And I'm keeping the cosine x as it is. And then cosine of 2x you can replace with cosine squared of x minus sine squared of x and then sine of x this way. So this is the part that I'm updating right here. Look at the red. You can write 2 sine of x cosine squared of x. I'm adding this for the two cosines directly above multiplied. And then you can distribute the sign, so it's going to be cosine squared x and then sine of x and then minus sine cubed of x over here. Look very carefully. I've distributed the sine x over. Notice these two here, the first ones, they both have a sine x and a cosine squared x, so it's going to be 3 sine x cosine squared x minus sine cubed x this way. And then cosine squared x can be replaced. The goal is to have only signs at the end. So 3 sine of x, I'm going to put here 1 minus sine squared of x and then minus sine cubed of x. I distribute the sine in the 3, so 3 sine of x minus 3 sine, be careful, cubed of x minus sine cubed of x. Look at the color coding if you have to. And then it's going to be 3 sine x and then negative 3 and negative 1, so minus 4 sine cubed of x. How can you be sure this is correct? The single most important or powerful tool is just graph it if you have to. Go back to the original. It was sine of 3x. So type in sine of 3x. This is an identity. Supposedly it's equal to this curve. For every x, you get the same y. So 3 sine x minus 4 sine quantity cubed x. Graph them both. And you see how they overlap perfectly. Look at the curves right here. They overlap perfectly. Had I made any mistakes, then where I began over here and where I ended would be unlikely to produce perfectly overlapping graphs. One thing that's very useful is just go and do this, graph this. Graph it, just graph every single stage of it, and you will see at each stage, as long as what you're doing is algebraically correct, you're producing ever and only the same graph, but just in different looking forms. So again, the key to getting good at math is limitlessness of the mind.